Hi, my name is Boris Savelyev. I'm engineering manager at Bolt, and I would like shortly present Bolt's long journey with databases and the experience what we have with TiDB. First of all, what is Bolt? Bolt is one of the fastest growing tech companies in the world, with 100 million customers in 45 countries across Europe and Africa, as well as over 3,000 employees. I know there is another Bolt in the valley, so need to clarify what my Bolt actually does. We do ride-hailing, also known as a taxi service. We provide rental service, scooters, delivery, car sharing, and grocery delivery services. To make this possible, a lot of people are involved across the world, and obviously we are hiring. Okay, that was a short introduction, the official part, let's say. Now we are talking. What we have from a technical perspective to run the business. We have several product teams who are developing thousands of microservices. But as usual, it's almost nothing because everything is data. So we have several hundred terabytes of data in more than 300 schemas with a data pipeline on Kafka, and everything is running in AWS. Why not MySQL anymore? We were very happy with MySQL for quite a long time. But one day we found that we grew too big for MySQL. And according to the second slide, that was fast as well. Another side of this is how to operate such big databases. MySQL storage, let's say, is not optimal. For example, in non-blocking mode, adding a column might take a week on a loaded 1 terabyte table. There are also new business requirements. When you have such big business, availability expectations are higher, and at some point, even a master switch may produce not ephemeral losses. Business growth pushes everything, how to develop and deploy new microservices. This is where Kubernetes helped us for stateless, but running classic relational databases in Kubernetes is a scary thing. Unless it was designed for clouds. Why TiDB? One of the main reasons why it's open source. You can change it, you can hack it, and it will work. When we speak about data growth, scalability is another important thing must have. Speaking about cost efficiency, TiDB storage engine has compression, and one example, 4 terabyte MySQL database after migration to TiDB became less than 2 terabytes. From our experience, the average compression rate after the migration is around 3, but it depends on the data. Sometimes it's more, sometimes less. If you run infrastructure in AWS, another way to save money, use ARM architecture. And actually, it's not only about price. One ARM core is cheaper, but compared to non-ARM core, it's a real core without hyper-threading, which is especially important for TiDB. Also, you may need enterprise support or special improvements in TiDB, and you can get them. And thanks to PingCAP, TiDB supports Kafka. Unfortunately, if you pick one new technology, that doesn't mean you can immediately switch. And some things need to take into account. First of all, MySQL compatible doesn't mean MySQL itself. Please read, 10 times or more TiDB documentation about limitations and incompatibility. Next, at least for me, it was not so easy to change my mindset from classic database with a primary replica narrative to TiDB regions with Raft. It's not the same. Multi-master is easy to understand, but not so easy to explain to clients. Apparently, they should know more about database topology. For generic proxy SQL administrator, it could be unusual to see many masters for one host group. Even if you think that you know how to adapt and have read TiDB documentation 10 times, you still may not see the whole picture. Some challenges, like I said, are about mindset and understanding how distributed databases are working in general, but some are very practical. For example, downside of distributed architecture, you may see increased latency because of more network communications between database components, or some features which you already used to see in MySQL, like special data types, are not in TiDB yet. The good news is that TiDB is moving so fast, so you actually need to reread documentation every 6 months at least to catch up on all new things. A little bit more about auto-increment issue. Regarding to TiDB documentation, for performance reason, auto-increment numbers are allocated in a batch of values to each TiDB server. This means that while auto-increment numbers are guaranteed to be unique, values assigned to an insert statement will be only monotonic on per TiDB server basis. Do you understand what it actually means for you? For us, that means if application business logic relies on auto-increment primary key, you fail. Once you have at least one query with order by ID, application behavior is unpredictable. The solution is in the picture. Add a new field with timestamp and order by timestamp to get almost the same behavior. Why almost? Timestamp precise might be not enough if your application does a lot of inserts. To set it more strict, we also define the timestamp field as unique and include retry logic on the unique key violation. Another good news is that it might be changed, and there is an issue in GitHub with a specification of how to make auto-increment more MySQL compatible. To conclude, what we have now, we have a lot of data migrated from Vitess and Percona MySQL to several TiDB clusters. We share TiDB clusters for around 10 schemas per cluster, depending on the load profile. After 6 months of active migration, we have some custom tools for migration itself, backups, and additional schema and table level metrics, like how many queries per second we have for exact schema in a shared cluster. As I said, we replicate almost every change in database to data lake, and it will be impossible to go with TiDB without Kafka support in TI/CDC. Also, we are using our format for change feeds, which is quite fresh in TI/CDC, but already mature for use in production. PingCAP and community are very supportive, and thanks for that. And where we go? Do more migrations, definitely. Try out a columnar-based extension with TI Flash. Add AWS multi-region online replication for TiDB, and improve visibility for shared clusters. That's it. Thank you. And if you have any questions, please feel free to ask in TiDB community Slack. Bye-bye.